Oop.
Good afternoon. Good afternoon, colleagues and guests. Today, we're going to have an interesting conversation with Michael Wiggin, who's going to talk to us about sector coupling of electricity and thermal systems. This is an effect about large-scale district heating, which is an older term you might be familiar with. And this is a fantastic opportunity to actually reduce greenhouse gas emissions, and he'll present the case for that. This began as a project about back in 2023 with the leadership of Bob Walker, who I believe is participating in this meeting today. And at that time, we were looking at how to link the heat from nuclear power with district heating. And, the net result is what Michael's going to talk about. He's a regular participant on emerging opportunities for sector coupling. For example, as some of you may know, here in Ottawa, the federal government made a major overhaul of its district heating system along the Wellington Street corridor. And Michael was an advisor in that process. It was a multi-billion-dollar project. And he, of course, has spent much of his career as a researcher and leader of a team at NRCan, Natural Resources Canada, where he was responsible for basically active activities in engineering systems research. And he is a retired engineer today, but he's very active in a number of areas, including some recreational things like building stone homes. He took some time off his career to do a project like that. So that's kind of an interesting digression from the heavy lift of the technical engineering. So I'd like to pass this over to you now, and I've also point out that Michael has to take a leave unexpectedly about 2:45 this afternoon due to an urgent meeting with the senior advisor to our Minister of Energy, and the Minister of Enercan, I guess. So Michael might add a little bit more on that as we begin. So over to you, Michael. Floor is yours.
Okay. Thank you very much, Peter. Uh, yeah, as I said, we've got this urgent meeting, but I think it's a good thing for all of us. We're starting to get the attention of Minister, Prime Minister about new opportunities in energy systems. And we've got a lot of meetings coming up with thermal utilities, municipal groups, and so forth. A quick mention to all of you is next June, there's going to be a major international conference here in Ottawa. And hopefully many of us will have a chance to get good Canadian content and innovation in there to show the world what we can do. I've already got AECL engaged, for example. So anyhow, if there's anything comes up we can't cover during our question and answer discussions, I'm available anytime afterwards to talk with you and answer any questions. So thank you. Here, sector coupling of electricity and thermal energy systems. This is something that isn't in our culture in Canada. People have electric systems, gas systems, water systems, sewer systems, but we don't have thermal systems. This is becoming rather rare now, as most of the northern countries in similar climate showers have this as a normal piece of business. And China, for example, is moving incredibly quickly in that. And part of that has enormous implications on fossil fuel displacement, greenhouse gas reduction. Um, Before I go on, I just wanted to do one reminder. Things like thermal systems or energy systems are really important, but there's some bigger picture things here are how we couple emissions, material extraction to GDP growth. And on this graph on the right, at one time we were decoupling, so to speak. Our GDP was going faster than our material extraction. But in recent years, this has turned around now, material extractions exceeding it. So there's a correlation between GDP and these other important issues. And that, uh, if they're not addressed, we are going to have trouble with climate change, biodiversity, and many other things. But let's start with what we can deal with today, and I'll get started. First of all, I'm going to talk a lot about nuclear CHP because it's such an enormous opportunity right now. Uh, but this nuclear energy focus, which is a big thing for federal and provincial governments, some of them, it's a catalyst to justify thermal energy systems. And once you have the thermal energy systems, that's good for other waste heat sources, renewable energy source, energy from waste, and very importantly, the storage of energy to do seasonal load management. But we'll be talking with about the nuclear opportunity first. By the way, there's about 51 of these nuclear CHP systems heating district heating around the world, and there's no reason why we shouldn't be doing the same. Um, First of all, what's a thermal network or heat network? Um, Most people haven't even heard or see it, but what you'll find out is they're pre-insulated, shallow buried pipes. They only have to be buried deeply enough for structural protection, not for heat loss reasons. So, like as you see on the right picture, you have a couple of pipes down about 600 millimeters meter, um, excavate, put them in, and then backfill and get on with it. And so they're a bit easier than people think of. And in residential areas, you might have a single pipe with supply and return inside that can take up very little space, just like your current gas line. So there's a lot of advancement in this field, horizontal drilling and other techniques about how to install these things in dense cities, for example. And so this technology is advancing quite rapidly. Um, the key problem, though, and this is really important, people casually talk about electrifying building heating, but the peak load, that's the issue. They talk about energy per year, dollars per kilowatt hour, or whatever, but they don't really address the peak load issue. And the capital expenditure in both distribution and generation is a function of peak load. And so, if we're going to electrify things in Ontario, the heating load might be in the order of 50 gigawatts that's on natural gas. The electric load's currently about 23. So, if we think we're going to electrify that by 2050, it's an impossible task for the electric industry. They're all fearful of soaring prices because of the soaring electric demand. And uh, IESO, the Independent Electric System Operator, uh, they've only built in about 7% of buildings to go on heat pumps by 2050. That's their assessment. So we've got a massive disconnect between our policy and what the electric utilities think are possible. So, and the next thing is they say, oh, yeah, we'll just build more nuclear, decarbonized energy, but they don't understand what's going to happen to the utilization of those of our electric system. If you electrified through heat pumps most of our system in Ontario, the utilization or capital use factor would drop from about 67% now to about 23% by 2050. The only way you can do that is jack up your electric price by two, three, or even four times. So I don't have the firm answers on it, but it's really important that this be studied better. Just to show you the difference, on this graph, you've got the blue line horizontally, that's our current electric load. And if you look at the red lines, that is the incremental heat load if you were to put natural gas in urban areas on heating and lower density areas on ground source heat pumps. And so you can see the nature of the curve is totally different, and it would be a totally different business for electric utilities. Next, um, I don't know if you're familiar with load duration curves, but if you took the load for a year, it kind of goes up and down hourly all over the place. Engineers in the thermal business, they rank those hourly loads from highest to lowest, and you get a curve for heating that looks something like the blue line. This is called the load duration curve. Now, So you start off, heating is only 25% utilization of the peak capacity. With fossil fuels, gas boilers are cheap. You can handle this kind of load. But if you eliminate fossil fuels, you got a problem. And then the next thing is if you put in air source heat pumps, our concern is that in the coldest day of the winter, it still requires the same peak load, a COP of 1, and using backup electric and other stuff. But during the rest of the year, the increased efficiency of the air source heat pump drops the utilization. So if you look at just the heating side, the electrification of heating will drop your utilization of installed capital from about 25% to about 10%. Great for customers. They think, hey, we're using less energy, but for the utilities, this is terrible. And they're worried. I think Bryce Conrad, the CEO of Auto Hydro, said in the paper about a year ago, we are going to face soaring investments required in our electricity system because of soaring electrical demands. They're worried. Okay, perhaps I'll skip over this one. It was just that we did an analysis of building densities, and we found out that we could probably serve like 70% of the buildings on thermal networks like district heating systems. And if you go to the lower density areas, we could look at ground source heat pumps. And in fact, installing a ground source heat pumps will save the utility a lot of money in peak load capacity, and we could afford to give a much stronger incentive for ground source heat pumps. I'll just move on. Quickly, if we look at nuclear right now on the left, we have a business model. For example, I took this out of a British report on nuclear CHP, but a reference case might be 500 megawatts of heat coming from the reactor, and you get about 175 megawatts of electricity. So during the year, this is the business we're currently looking at. Generate electricity and try to get it base loaded. Now, what they could do is, let's say if you had a heat load equal to the rejected heat, you would serve a heat load like so. That might be about 350 megawatts. You lose a bit of electricity when you extract heat from the turbines, but you end up with selling more energy. Now, the last case is, but what about all that energy that's generated during the lower heating loads of the summer, in the summertime? You can put in thermal storage, and then you could use all of the heat from that nuclear plant all year round, put any surplus into storage, and during the times in the winter, you could take heat out of storage to increase your peak capacity. So you've got like three business models. Business option number one is what we're focusing on. They could move to business option number three, greatly increase the impact of the nuclear power plant, and actually generate extra revenue that could offset the electric costs and stabilize or even bring down electricity prices. This is being investigated now. In terms of storage, uh, people haven't heard of this, but this is becoming increasingly commonplace in all the countries that have thermal networks. Uh, One super example is in Vanta, Finland, and they have 90 gigawatt hour storage. That's enough heat stored to heat a small city for a year. Okay. It's caverns underground, about 1.1 million cubic meters. Because of the depth, it's under pressure, so you can actually heat it higher with surplus electricity and things like that, higher than the normal boiling point, and because the pressure will stay liquid. This is going on in Finland. China is building one right now, double that capacity. So I think uh, thermal storage should really be a very principal part of our thinking, because with thermal storage, you can manage loads for months, whereas electric storage batteries, you're talking about hours and days. And it's not technically possible to do seasonal storage. Also, it's about 100 times more expensive than thermal energy storage. So this is totally overlooked. I think the federal government's got one guy working part-time on it and needs a lot more. Um, Next, if we were going to change to nuclear, I'm working with the communities like Durham region in particular. They're comfortable with this. They like the idea of extracting heat, but change is being resisted by the people that have a stake in the existing business model, base loading power plants, electric only. They are concerned. I don't want to uh, undermine the concern some of the nuclear power plant designers, operators have. It is going to change things, and they're worried. So we need to increase their comfort. Now, what I also found out from, and I in this British report, but I verified it with a lot of nuclear operators in Canada. If you get in at the design stage when they design the plant, you could equip the turbine section with extraction ports and so forth for an incremental cost of about 0.2%, less than that. And so if we were to do that, even if we don't have a heat load today, like at Pickering, this incremental investment of 0.2% would allow us to potentially heat all of Toronto from Pickering. So it's really urgent we think about this now. And this is the message that I'm taking to the minister's office this afternoon. They can influence this. They invest a lot of money, got a lot of policy in it. But if they get CHP now, it'll be very inexpensive to prepare for the future. Now, so I think if we did this, you get really unprecedented reduction in greenhouse gases. Nuclear plants alone put out more than the province of Ontario heating loads on natural gas. But then you open up for industrial waste heat, typically 30–40%, often comes out as low grade heat. Stelco years ago evaluated, and they're willing to heat all of Hamilton using cooling water from their blast furnaces. Um, it would make, with this extra revenue, the nuclear plants would become more cost effective, potentially doubling revenues depending on final prices. And then, and as we get to smaller SMR, small modular reactors, micro modular reactors, then they can be deployed closer to thermal and electric loads. Prices are a bit pricey right now, but that may come down. We'll see. So um, the big thing is the massive reduction and expansion of the electricity system. People haven't really looked at that. We've addressed that in a report from the Boltzmann Institute, and they could really cut back a lot on new generation required using thermal infrastructure instead of electric. And then the nuclear plants could increase from about 33 to 90%. And then once you got these thermal systems, you're opening the door for all kinds of other renewable and waste heat utilization to make further improvements. And lastly, electricity prices. This could improve the utilization of the electric system, lower the expansion cost at today's dollars. Most of our electricity prices are based on past dollars. It's going to be a lot more expensive. And we may be able to stabilize or even lower electricity prices. Um, for your reference, the Boltzmann Institute, we have our executive summary, our pathways report, and then also you should look at the OSPE, the Ontario Society of Professional Engineers. Uh, they have taken a position on this, and they are advocating the expansion of thermal networks and also of nuclear CHP. Um, so in the end, if I'm talking to the nuclear industry, so what what does the nuclear industry business want to be in? And I think we've got some very attractive options. And then the important issue to the policy people I bring up this afternoon is what business does Canada want them to be in? Right now, we don't have a thermal network policy, don't have a thermal energy policy, we don't have a policy on combined heat and power, but it could be of such benefit to the country that we should be after them to do it. So, okay, so that's my presentation. I'm sorry I rushed through some things, and I'm very pleased to go back as requested during question and answers. Thank you very much.
Thank you very, excuse me. Thank you very much, Michael. I would like to open the floor to discussion in the form of questions, comments, and I would like to ask the first question, and maybe you could elaborate a bit further just on what the Boltzmann Institute does and where it could fit into the equation that you just described for the country.
Oh, well, Boltzmann Institute, we were initially mostly retired guys that had all worked together at one point or another. We had one of the foremost electric system experts, Paul Accioni, is on the OSP committee and on Boltzmann. Um, we've got he was also involved in nuclear heat generation design and operation. We had others who've been district heating and the electric system, former Ontario Hydro people. Some like a physicist, Martin Green. He's done things like vibration problem solving in nuclear reactor tubes, but also doing incredible amount of research on simulating loads, both thermal and electrical. We have a couple other people that were major players in the real estate investment that advise us, like the head of Brookfield. Uh, Another was the head of Morguard. So we got a wide spectrum of people who shared the concern that the current policy of electrifying building heating was flawed. So we got together and we were able to attract about $750,000 worth of support from Environment Canada through the Net Zero Advisory Board to study the two pathways, thermal networks or electrification. We've that report is done, published, and we're getting lots of speaking engagement requests to elaborate on that. So, that's our major project, and we're just looking at next steps. I think the important one is creating linkages with other association of similar concerns to try and build up our power in terms of lobbying or promoting a more sustainable future for Canada. So that's who we are. Retired, but busier than I've ever been.
Thank you, Michael. I'd like to ask Dave Doherty to turn on his camera and so on, and you can pose your question as you had it in the discussion. Go ahead, Dave.
Thank you. There's a little bit of construction work going on in the background, so I'll make this fast and then mute myself. I would like to know what you think. What roles could sand batteries play at scales from the household to industries to cities?
Uh, yeah, sand batteries, very interesting. I was following work in Finland on this, where they got a few prototypes, and there's another bigger one down the States. I think that really they could be a very valuable resource. The only reservation, not a reservation, but they fill a particular niche. They are very high grade energy, and they require high grade energy to charge them. Uh, if we have a load management issue with electricity, it's a great place to dump electricity because the electricity doesn't care what heat it's making, doesn't affect the efficiency much. So there really is a role for them, especially as we move more into decarbonization of industry. But in most places, we try to keep in mind exergy analysis. Uh, uh, Building heating is like the garbage dump for energy, very low exergy requirement, and you can use reject heat from all sources. Having said that, though, sand batteries and other high temperature storage could play a very important role, especially if we have surplus electricity, like renewable electricity.
Well, directly related, is there a possibility of having a nation building project that would involve being able to produce sand batteries in Canada?
Yeah, I think that would be of interest. That would be a good idea. Also, there's cavern storage, which is the other one for lower grade energy. So there's quite a range. And there's also another Canadian company that's devised a technology to go into the lower floor of an underground parking lot and drill 200-meter vertical boreholes to make borehole thermal energy storage. So whatever it is, we have to take a full advantage of load management capacity for thermal energy storage. And within that, you'll find these, the high temperature ones will be important as well.
Right. Do you get the sense that there are actually people in Canada, either politicians or industries, who are seriously looking at this stuff, or are we just going to fall back on things like liquid natural gas?
Well, they've got a real conflict. To be honest, I was reading again part of Mark Carney's book Values on climate change, and he really, really does understand it. But then when you think of all the pressures, like right now, let's say Daniel Smith and the fossil fuel business lobby, trying to reconcile that as prime minister is a very different responsibility than when he was head of UN finance or whatever for environment. But I really do think it's an education awareness project, and we got to, if we show the consequences, and this is why I think maybe doing a value proposition, if we were to have such networks and such thermal storage things, what would it mean to Canada? And rough out the value to Canada. And that way, I think that's what the politicians listen to. And if they don't, if their constituents start to listen, they get worried. And that is happening. Okay. So I think the Minister of Energy, his riding includes Markham District Energy. It's got biomass, wastewater heat pumps, cogeneration, thermal storage. So he is, I think, potentially very receptive to this. But I'll report back to you and see what the feedback we get today. But I
Excellent.
think awareness is critical. We get awareness, so we get growing comfort with our engineering community, policymakers, and others that this is not crazy. Every other country does it.
Okay, I'd like to I'd like to ask Art Hunter to stand on deck, and I have a brief question. I'm just wondering, can you expand on the work of? Sorry, can you? Is there any role that the new SMRs at Darlington are being discussed as being put in there? Any role for them in any thermal network opportunity,
Yeah,
either locally there or within the region?
I understand there's a consultant, I think it's Hatch, is actually working on the implications and how to do heat extraction. I'm working with them now. And they gave a paper at the Canadian Nuclear Society conference recently on this. So there aren't a lot of really big heat loads around Darlington, but there is the possibility of doing a major thermal corridor going from Darlington, Pickering to downtown Toronto and beyond. So if we can capture the really big view of, do you want to build a new nuclear plant, or you want to use the waste heat from the one you've already got or going to build? I think if we can crack that nut, then we can get people more open to major projects, such as a major thermal transmission corridor and district heating. So the person I'm meeting with this afternoon is the senior policy advisor and major projects advisor to the Minister of Energy, and we'll be raising this with him.
Okay. All right, Art, over to you.
Yeah, Michael, I keep thinking of the major networks that are heavily engineered that already exist, and we call them our sewage and storm sewage networks that are underneath every city, and everywhere you go, there's a manhole cover, and you just have to look for them, but they're everywhere, and they connect to every building, and there's a lot of waste heat that is being, as it were, dumped out into this network, and ultimately either heating the ground, or if it's warm enough, the ground is heating that water. How do you see this taking advantage of these already existing major networks of pipes in every city?
Yeah, well, that's a great question. My background is actually more on that end of public health engineering, if you will. They, it is a very active area of interest. Like in Sweden, for example, ever since the early 80s, they've been taking sewage treatment plant effluent and using that as the heat source. That way, they're not messing around with the distribution system. Um, and then also, it's got cleaner effluent coming out that they can run over heat exchangers and so forth. However, the point you make is being recognized. There's a company in Toronto now that's focusing and putting heat exchangers uh, down so they can take heat out of the major trunk sewers to heat the Toronto Western General Hospital or whatever. Uh, the engineers with Peel County are looking at this and advocating data centers dump their heat down the sewers and they'll pick it out again with heat pumps. So there's some debate on that. You lose exergy when you dump heat from a high temperature and dilute it. But you don't want to second guess anything and give it a fair shake. But there is active discussion of that on, and it's quite widely done around the world in different ways.
Excellent, thank you.
Yeah, I think actually another thing I saw years ago was in Germany. They've got double pipe sewer pipes where you have sewage going down the center, then a space around the outside, another pipe. So it's like coaxial pipes. So you circulate the heating fluid from the heat pump through the outer jacket, and the sewage flows down the middle. That was a commercial product made some years ago.
Very clever, I like it.
Yeah.
Okay, thank you. I'd like to ask John Hollins to stand on deck. And I got a question from Bob Walker, who had to leave at 2. So Bob is proposed to ask Michael to describe what's the connection of the thermal network to the household would look like with household cost implications.
Oh,
Bob says, I think this is a very positive story that plays to affordability.
yeah.
Can you
That's really
unpack that for
important.
us?
Uh, yeah, I looked at this because I've been talking to the gas utilities about changing before they lose all their customers, change from a thermal utility to change from a gas utility to thermal. Instead of buying and selling gas, buy and sell heat. Okay. And in that investigation, I went to a leading mechanical contractor and we priced out a hydronic air handling unit. And I said, I want it to be the same size or smaller than an existing furnace. So you can slip it in, pull out the combustion chamber and slip in this. I got a price of $5,000 on a one-off. That would be about 20 kilowatt peak load, typical house or a big one. And so that's 5,000 bucks, but it could be a lot lower later on. And then to add to that, that could be done in a couple hours. If you've seen a furnace change, if your furnace is burnt out, they come in 2 hours later, you got a new furnace in. Same with this. So if you were to put in that unit, now you need a couple of holes drilled through the walls. That's no problem. They do that all the time. And then that would connect to a hot water pipe, 2 pipes on the outside. So you supply hot water, let's say 90 degrees to one and take it out at 40 or 50 back into the pipe. And then in the street for the residential areas, you have twin pipe. You have 2 pipes of supply and return with inside one jacket. Okay, so it doesn't take up a lot of space. So that could go down the same right of way as your gas line. Okay, so that's oversimplified. Once you get in urban areas, it can get a lot more complicated. But I just want to say it's not that big, and uh, because of in the province of Quebec, they're starting to try to stop expansion of natural gas as a way to lower fossil fuels. The gas company in Quebec, Gazifère, a branch of Enbridge, they are working right now on district energy project to take waste heat from a Gatineau pulp and paper mill to heat the east end of Gatineau. And this group in Quebec is seen as the think tank for Enbridge, Ontario. So they are looking at these things, and it looks quite affordable. Now, in general, I'll give one caution. In many areas, district energy thermal networks can compete with natural gas. Okay. In other areas, they may be more expensive than natural gas, but they're decarbonized and they're much cheaper than electrification when you do full cost accounting for the plants and everything. So we're going to go through a stage where the business case may not always be there for people on gas, but if you want to decarbonize, the business case is there instead of electrification. So we deal with that, and I think it's being actively looked at by the gas industries right now. And as you'll see in Europe, like 98% of Copenhagen, Stockholm, and Helsinki are all on district heating. And that includes also subdivisions, low density areas like we have. So you can do it. It's a matter of awareness and uh, public policy and will.
All right, thank you. John Holland, go ahead with your question or comment.
Thank you, Michael. Um, uh, I think your case could have easily been made half a century ago, and and Ontario has had this fleet of large reactors in southern Ontario, not too far from demands for heat, I would have thought. So why hasn't it already happened? Is it a question of management not being interested, or is there a political impediment in the way here, or just that people simply don't understand? Are they Trumpian?
Uh, yeah, you'd almost think so. I think basically the big problem is in Canada, gas has been cheap and we have no fear of security of supply. So why think? Yeah. Next thing is, especially on nuclear reactors, it means changes perhaps in regulatory regime and some changes in design, some changes in operation. So you've got a group of people that are used to a business model of base loading electric load. And the idea of playing around with electric heat, varying that and other points is scary to them because they don't have familiarity. One of our colleagues here said he's been in the business, the nuclear business, 40 years, and he'd never really even heard of this stuff. So this awareness of the possibility of doing it is not there. It's not there among most of our engineers, not there among most of our policymakers. And it's been a real uphill battle getting things done, but it's happening.
Have those long-term concerns, the issues that you mentioned, the explanation you offer, which makes sense, do they still apply, or has something changed in Ontario that might open the way to do what you're proposing?
Um, I think the short-term project we want to do, I'm going to try and pull some people together on it, is work for an illustrated model of how it would work. Let's say, forget the barriers, can't do this. Say, okay, if Pickering was, with its 4 units, connected into a thermal network, and you could operate with varying the proportions of electricity and heat, and also actually varying reactor output. This is becoming more common. How would it all operate? And I'd like to get the very best of the mechanical engineers doing the plant design and getting the very best. We've got one of the leading companies in the world working on thermal networks to put it all together. And if we can create that story, then we've got something more concrete for people to look at, kick the tires, and agree or disagree on. I think if we do that, that can really move things forwards. So that's my project I want to try and pull off over the next couple of months.
Thanks.
Thanks, John. Good to see you again.
My pleasure.
I figured you gentlemen might know each other. Art Hunter has another question, so Art, go ahead. Michael has been involved in this. Go ahead, Art.
Yeah, so I know that Parliament Hill has district heating with multiple buildings involved. and that's been around for some time. Is it in need of modernization now, or has it been upgraded over these past several years?
Yeah, that's a very interesting one because originally Public Works wanted to just sell off the system and get a private operator. Okay, and then they asked me, excuse me if I talk about myself, they asked me to come as an advisor to them to see if there's something better because of my experience. And I convinced them that if they just sold the aging relic they had, that wasn't responsible, and they should look at committing to modernize it, either themselves or have a partner do it. So then they agreed, okay, but they were leery about hot water because nobody there had any idea about hot water technology. They're all steam guys. It's the same as like the nuclear community today. They're all electric guys. They don't know thermal stuff. And in this context, they didn't really understand hot water compared to steam. So I took them up to some colleagues in St. Paul, Minnesota, who had gone through conversion, and they were amazed at how it worked. And then next, I took them over to Europe to see systems there in Sweden, uh, uh, Sweden, Denmark, and so forth. And so they said, oh, yeah, I guess maybe it will work. And then I worked with the architectural people of Public Works to establish what temperature would be possible to operate off when you have a lot of existing buildings. So they kind of came up with an agreement that 65 degrees should be possible. Maybe 70. So we set a 70, which is a common temperature now in the European system as a supply temperature. I will confess, when you've got old buildings used to have steam heating in them, the conversion isn't always simple, but I think they wrote it off as an infrastructure investment, not necessarily having to calculate the payback on everything they did. So now you've got a system in Ottawa that is working its way down so it can operate off 70-degree heat. In the short term, for in the old buildings, they accepted 95 in a transition. And they've also got a private partner that did all this. And now they're interested in expanding and serving non-government buildings. So this would be an incredible national project because in our area, there's interest on, let's say, SMRs, MMRs, and they're looking at some of that. There's also massive amounts of wood being wasted in the Ottawa Valley. We've lost about 12 million tons a year from mill shutdowns. Out of that 12 million tons of wood chips a year, a lot of that was waste wood that had red rot in the core, couldn't use for saw logs, but it was fine for pulp and paper. We only need 100,000 for public works. Anyhow, that's being considered. So, so right now then, Canada has in the public works system, ESAP, it's called, one of the leading projects around the world. It's up close to world standard. And it is the biggest such conversion, I think, in North America. And it's going to have a lot of interest at the coming annual conference of IDA. They're hoping we're going to get the minister for ribbon cutting to formally open that system. So I think we're moving.
Is that related in any way to Le Breton Flats? Because to me, it's right next door and there's new build going on. It seems like an ideal connection.
Yeah, we did have a lot of discussion with windmill investments, but Public Works couldn't move fast enough. So they went and did their own independent contract with a paper mill, Kruger, to take waste heat and use in heat pumps. But for some of the rest of the development, there's already negotiations going on with some of the major developers there to start running off the public works system. But one of the big things that's holding up the developers and property owners is they say they're not interested unless it's green. So in the transition period, they're still running off natural gas and they want to convert that. So a lot of people would be much more interested once it becomes green biomass, nuclear, whatever, solar energy, waste heat. So anyhow, that's being considered. And then also, linkages back up to other public works centers around the city.
Okay, excellent.
How much has that project cost roughly to date? I mean, I gather it's fairly expensive
Oh,
exercise.
I'm sorry, I really don't have an up-to-date number. I should have it, but I think it was about, um, it was over 1.5 billion anyhow, a lot of money. But it was 137 megawatts of heat. And then at peak load, and by converting to hot water, that's dropped to about 100. So a massive energy efficiency improvement. Now they're still on natural gas, but then they go the next stage to get another source. Big project, but it's attractive one.
Thank you, Michael. Meg, go ahead, please.
Hey, Meg.
Hey, so good to see you, Michael.
Yeah, it's good to see you too, Meg.
Um, I've got, first of all, a comment from myself. I would never consider nuclear green.
Hmm.
We still haven't figured out what to do with the waste. It poses huge threats. It could be a target. There's certainly, evidence of radioactivity in the Great Lakes, and the SMRs have actually never been built. So
Yeah.
we don't really have we don't have a great, we have no record of success with all of these
Yeah.
SMRs. They're fictional. They're PowerPoint reactors right now. And there's good reason to think that they're not. Whereas now we can construct windmills, very quickly. We can put solar power up very quickly. And we know that they work. Anyway, that's my commentary. But I was kind of intrigued because when you're dealing with transfer of heat in various materials and various pipes and so on, liquid water is way denser than steam, and so you can hot water is going to have more energy in it than lower pressure steam or something like that. And you mentioned the possibility of putting hot water down pipes that are currently taking natural gas.
Well,
And
not the same pipe, same right of way.
oh, same right of way. Okay,
Yeah.
well, I was thinking this couldn't possibly work.
No.
Oh, okay, so you've got the right of way. So you could put you could put higher capacity electricity wires through that right away. There's lots of other things you might put along the right of way, but steam pipes or hot water pipes are amongst the possibilities. I'm not quite sure, and this is just my ignorance of this kind of technology, but how much bigger, or what's the sort of size difference if you were going to have the same heating capacity through some kind of standard heat pump, all else being equal? What's the difference in pipe size for hot water versus steam? And that's probably something you're going to have to specify a lot more, but I'm just wondering about the scale.
Yeah. There was quite a few questions buried in that. First, I would like to acknowledge that I worked for many years with Meg's late husband, Paul, and he was really important to me because we worked together as a bridge between policy and science, trying to explore different options. That work was incredibly important. Unfortunately, it fell on deaf ears, I think, so we're still pushing on that one. A couple of points I'd like to make, Meg. First of all, I am not a nuclear advocate per se. What I am is I'm an efficiency advocate. And if the government is going to choose, both federal and provincial, to build these things, I can't stop that. But what I can do is try and raise their efficiency from 33 to 90% and reduce all the heat that's been dumped in the lake, making thermal pollution that our First Nations are getting concerned about up around Bruce Power Plant. And so it's an efficiency measure. Also, the other reason, if they're going to build them, we can use it efficiency, but then it acts as a catalyst to build the networks, which then provides a way of using solar energy and waste heat, all the other sources. And what's really important, I think the biggest thing, especially when you incorporate the seasonal thermal energy storage, it totally changes the economics of thermal solar. Thermal solar, it's going nowhere in Canada except for domestic hot waters by some fanatics. But if you have a way of capturing all that high output during the summer and saving for the rest year, it totally changes the economics of many renewable energy things. Okay, so and I think you'll find, and we have done some work, and it bears more discussion, but we all want renewable energy, but you have to deal with the load demands. Unless we can get a population that's more receptive of having intermittent supply, managing the load is really difficult, especially on electric stuff at scale. For household collectors, batteries, it works well. And Art's got a wonderful off-grid house with solar collectors and everything. But these thermal networks and storage complement renewable energy and overcome some of the shortcomings about the intermittent or variable supply. Supply of hot water into a house, I think you'd actually have 2 3/4 inch pipes instead of supply and return of hot water instead of one, let's say, 3/4 inch gas pipeline. Doesn't have to be that big, but so it's not enormously different except for the information jacket. But as you go down the street, you have to consider all the houses and buildings, so the pipes get bigger, of course, just like a water and sewer system. Same thing. Small pipe connecting to the house, but bigger pipe going down the street.
I had no idea that you could manage to hold heat for
Yeah.
the
Can I
entire.
mention one thing that'll be, I think you'd find very exciting, is in China, they wanted to get rid of this waste heat from nuclear plants, but their cities are often inland, away from the ocean. So what they did, and they also have a water problem there. They need more fresh water. So what they did is use one of the nuclear plants to desalinate water. Now they've got hot desalinated water. They pipe it at the extreme 125 kilometers in a single pipe. And at the end at the city, they take the heat out to heat the district heating system. Then they put the cooled water into the water supply system.
Oh my goodness.
It's incredible. So Canadian engineers, they're capable of this innovation, but we need the policy direction and the challenge. Because if you're an engineer, consulting engineer, you still got to feed your family and have a paycheck in a month. So if there's no policy direction and no hope of business, your interest in learning is limited. So until we have a clear policy signal, we're going to be stuck in the same position of people are not redirecting their innovation into this area that all the other countries are doing.
Yeah. And they can't change their policy as fast as they change their underwear as well.
Yeah. Oh, you know what that's like, eh, Meg?
Oh, I might have heard about it once or twice or 100 times.
I know. Thanks for your questions, Meg. Good to talk to you again.
Yeah, great to see you. Thanks a lot.
Richard, you have a comment that
Yes,
may build on Meg, so over to you.
Yes, thank you. Michael, it's a good talk. I enjoyed it. My comment, it's really more of a comment. What you spoke about actually feeds right into a document that both Meg Sears and Jeff Strong and we submitted a document into the Envy committee on how what you do for the environment is actually good for the economy, and that's exactly, you're giving another example of that.
Yeah.
And I think you're giving another example of exactly just that. And you ought to emphasize that when you meet with the minister this afternoon, because that they often worry about the dollar signs and what it's going to cost, but you can emphasize that this would be good for the economy as well.
Yeah.
Not only that, but also good for people, public health.
Yeah. No, I've even been talking to people like steel industry, the Canadian Steel Producers Association, and like Ontario alone, just a very rough estimate, it could be like $70 billion worth of steel. So I said, if they're worried about Mr. Trump cutting them off, if we had a big thermal networks program, they could create a big opportunity for the steel industry here in Canada. And that goes for a lot of other things as well.
Right. Well, we also, I was part of a proposal that went into the Ottawa Hospital that would make it, go for a conversion from its energy supply to actually renewable, from wet energy, sewage, as the majority of its energy, and then the rest would be solar. And they're still not biting on it. They still have not responded to. We even met with their engineer and so forth, and they still haven't bitten on it. They still haven't committed to it.
Yeah. So I think I think often if any one of us or any one of our groups starts trying to tackle policy change or major change, it's very, very difficult. But if we can start finding who it is the government listens to,
Mm-hmm.
then work with them to understand the value of change,
Yeah.
then they can take the message forward and be listened to, whereas some of the rest of us may not be. So I think there's a really important part of strategy for any of us. Find out who the big stakeholders are that are interested, see if you can develop an understanding with them that there's merit, and then go after government with them in tow or with them leading, and you are there in a support role.
Richard, that is in a sense what we were doing with the Manor Park microgrid
You got it.
in liaison with the developer. Very similar.
Yes, that's right.
approach.
I'm working on that too.
Well, listen, I've got all the questions and comments that have been raised in the chat covered. So I'd like to suggest that we move now to an open session where Michael will just, everyone can be open to all talking heads, and we can have a discussion. And it will be end of recording once we give a formal thank you. So perhaps I'll ask, is it Art that's going to thank our speaker here for this presentation so that we don't run into constraints. He's going to have to leave in about 20 minutes. So,
Yeah. Okay, and I had thought, do we have Ted Manning on here? Yeah,
Ted, okay, Ted is here.
Ted, can you
Ted,
thank the
yes,
speaker?
there.
Yeah,
Yep,
if you let me on, I will be happy to thank our speaker. As it was, I was. It's like trying to get good news from anywhere. It's very hard to find. Two things strike me. Start my video. Yes, I can. Okay. Two things strike me. One is the barriers to acceptance of good ideas continue to be very hard to break. And certainly when I worked in the government, I did here we go. I did actually work on projects on barriers to doing sensitive land use planning, and I got resistance because they did not wish to identify the barriers, because mainly it was them. And the second thing is success stories. It strikes me that we talked a lot about some very interesting opportunities and things could make a difference, and ones like art and like perhaps the reuse of heat. But there does not appear to be easy access to a series of success stories that are easily shared. And when we talk to people, even when I tell other people about art, they don't believe it applies to them. Or when I tell people about the great solar work that was done by the Assiniboine banks much as 20 years ago to create almost totally off-grid banks in Winnipeg, where they were essentially off-grid and doing very well. These things are not easy to find, nor are they readily shared. And yet, anytime when we were trying to push people to actually adopt more sensitive and reasonable things, they were looking for a real success story very close to what their own needs were and wants were. So I think one of the things we've got to look for is the greater use of success stories and throwing them into people's faces if we have to say, why are you being stupid? Why are you doing things that cost you money? Why are you doing things that are destroying your neighbors when we have this nice model and it's not even going to cost you money? Anyway, that said, I was very pleased to hear what you're doing and all of the building blocks we are doing that could, in fact, be deployed. So I think our continuing challenge is to find ways to get to the right people and bend their minds. So we're really in a sociological rather than a technological mess. So thank you all very much for coming. And thank you, Michael, for an excellent presentation, good questions, people really interested in trying to make a difference. And I would ask those of you to share this with other people who you think might be interested and be able to use it. And remember that if you like the presentation, please say so. And for those of you who don't belong to CACOR, we would very much like you to belong to us, because it does help pay the bills. And that is increasingly an issue when we try to reach more and more people with these ideas. So thank you very much again, Michael. And we will be doing this every week as long as we can keep it up, sharing good ideas with each other. So thank you very much. And we'll now let you go and talk to each other, and we will turn off the recording.